Hi, my name is Joe Wright and this instructional video is all about the new things you can find in the UKIE Country Kit for Civil 3D 2027. This is part of a series of videos. As the author of the UKIE Country Kit on behalf of Autodesk, I try to publish videos annually to give insights into the new things we have included, and I make a point of ensuring the video is instructional rather than market focused. I also endeavour to balance the content so that it will appeal to a cross-section of abilities, with some basic principles included along with fairly advanced workflows. I tend to throw in little tidbits like hints and tips and even the odd undocumented secret into the narrative, so I would encourage you to follow the storyline. And for this year's offering, I've optimised things to keep the timescales down. I realise your time is important, so in case you are in a rush, on the handful of slides that follow, I do include a timestamp to identify any section that may be your main reason for watching. This video covers everything that was introduced in 2026.1 and the 2027 versions of the Country Kit. The first thing you will notice is a new ribbon bar, designed to give a heads-up approach for some of the previously buried tools and content. The content is pretty much up to date and references current standards like the new method of measurement stuff recently published in the Highways Manual, and if you've not used quantity takeoff in Civil 3D before, I'll show you whilst directly referencing this standard. Now, the big question of whether to use strict Uniclass 2015 layer compliance or adopt the GG184 variant is usually based on your discipline. Whilst the GG184 template has been around now for a few years, 2027 makes it easier with the templates immediately accessible on the ribbon, and the layer update tools now support round trip conversion. Most importantly, the compliance check will detect the layering system you're using and will report non-compliance. Now, we've always had a large collection of UKIE subassemblies, and we've added to the pot with some new wall subassemblies, including a gabion. We also have a new MCHW channel and some ducted underground service trenches. For those of you who are unaware, a new model viewer was included with Civil 3D 2026.1, and we've updated the code sets in the templates to take full advantage of this new tool. But code sets are not just for 3D, and I will, where possible, introduce shortcuts and highlight the benefits of working with code sets as we work through the video. We now have rail catalogues for all three of the network rail standards. I won't be covering these here, but I do hope to publish another video focusing purely on working with turnouts later in the year. Support for CD116 roundabouts, based on the roundabout engine in vehicle tracking, is new for 2027. There are 4 roundabout types supported: compact roundabouts, mini roundabouts, and 2 types of normal roundabout. We will be designing a compact roundabout in the video to highlight the challenges of roundabout design. Now, the way you actually download UKIE from Autodesk has changed. You will need to visit the subscription centre to get it. Look for the Civil 3D product and select View Details. This will take you to another screen, and under Available Downloads you need to choose Libraries, where you will find all the country kits. Just press Download next to the UKIE one. Before we begin, if you can think of things we should be including in the country kit, for example a standard that may be missing or an idea for a new assembly, then please feel free to drop your suggestions in the comments. So let's open the box and let me show you what's inside. First things first, we now have a ribbon bar for UKIE functionality. This just makes things easier to find. Like up here, as you can see, you can access all the previous videos that I've published. And next to it, well, it's a quick link to this year's user guide. By the way, and as we now have the user guide open, and maybe you didn't know, all this documentation is indexed. So all you need to do is find the topic you want on the content page, like the section about the ribbon, for example, click it and you'll be taken straight to the page you want. But on the whole, the ribbon is a quick and easy way to get to content that has historically been buried elsewhere. Look, as an example, the combined geometry report is in the toolbox and it is 4 levels deep, needing 6 clicks to launch. Alternatively, it's right here on a new ribbon, 1 click instead of 6. Same for some of the tools like the layer update tool or the 2D sign generator. So it's 1 click and you get straight to what you had before. No messing around, no taking your eye off the prospector. And as a matter of fact, one of my colleagues tells me that since he started using this new ribbon, he has hardly ever needed to go into the toolbox. Worth mentioning at this stage, and it may not be common knowledge, but there are 2 current UKIE templates. One that supports uniclass layers as defined by the NBS, and one that supports the standard for highways GG184, which is sort of a variation on the uniclass layering system. You can start a new drawing using either of these templates by simply pressing the relevant button on the ribbon, and you can make whichever you need to be your default template by selecting this little flyout. 1 simple press and your default is now, in this case, GG184. Now, if you're a landscape designer or you interact with other BIM models, you will probably want to use the NBS one. Alternatively, if you design roads, you probably want to use the GG184 template. But don't worry too much if you've been using the wrong one, because the layer update tool now supports a round trip conversion between the two. This drawing, for example, as you can see, has layers in the NBS format. Running the layer update tool will figure out your current default and will move the layers over. Let's do it. Okay, it warns you it's going to do a lot of work and just wants to make sure you're happy with such a big change. But after you've pressed OK, it just gets on with it. And in the end, it shows you a report on what it's done. And Bob's your uncle, Fanny's your aunt. All your stuff is moved over to GG184. The Uniclass Layer Checker now even understands all this and will generate a report for layer compliance even though your layers comply to GG184. Anyway, have fun exploring the ribbon bar. At the very end of this video, I'll show some advanced ribbon management techniques, so hang around. Okay, let's move on. This drawing contains a simple alignment and a profile of an existing road, and I'm going to use it to show off the new UKIE specific subassemblies. Of course, the tool palette is still an important resource. Whilst many items are now on the ribbon, it is still the place to go for assembly sets and subassemblies. Here, for example, I'll drag a pre-built assembly that is a general road cross-section, and I'll make a corridor using the alignment, the drawn profile, and the inserted assembly, ensuring I target the existing ground surface for the cut and fill. Boom. And here we can see the corridor outline in the plan view. Let's click back on the Prospectus tab and we'll say bye-bye to the toolbox for now. I don't think we'll need it again. And here we find the corridor. And I can change its name to something more useful by using corridor properties. If you look on this corridor properties tab, you can see a tab that says code sets. Now, if you're not familiar with code sets in Civil 3D, this is how it styles things in many items like the corridor, the assembly, the sections, and lots of other places. They're pretty important because you can join these together, create things from them like feature lines and new surfaces, extract them and do all types of cool stuff. The old UKIE Plan and 3D code set is now no longer the default, and to replace it we have 3 new sets. These ones. Don't worry, they're pretty similar to the old one, so you're unlikely to notice too much difference. The main advantage is that the display styles in these new code sets have been updated to work well with the newly introduced model viewer. The idea of the model viewer is that it remains permanently open on your second screen. You can add objects by right-clicking that object and choosing one of the 2 model viewer commands, like here on the corridor for example. Once opened, there are simple settings to change what is displayed and how things look. It's pretty straightforward to navigate around the model, and it's a great improvement over the older object viewer. All of this, of course, is dependent upon the styles you use being contained in the code set. Here you see how the model looks with the default code set, UK Plan and Model. And if you use the old one, UK Plan and 3D, it doesn't style very well. Same model, just using the older, crappier code set. The other new code sets differ mostly in colour combinations. The grayscale one is not quite black and white, but it uses blue, grey, blue, green and other greyy, is that a word? Greyy colour shades. And the vibrant one just goes into sort of a 1970s Technicolor mode with contrasting shades. To get the most out of the new model viewer, you will need to use these new code sets. I always have the model viewer open on my second screen, so I'll move it back there for now. You can still use the older object viewer. It still works, but this will be the only option if your graphics card doesn't support fast shading. I'm going to delete the subassemblies attached to the right-hand carriageway. This updates the corridor. And I'll just take a second to reopen and reposition the tool palettes, selecting the UKIE Design tab, which contains all of the newly added subassemblies. Let's take a look at them. This one is new, a drainage channel block, directly matching those specified in CD 524. I'll add it to the edge of the carriageway. Now it defaults to a Type A, but we also have Type B and Type C too. All UKIE subassemblies have help files attached. These are always worth a look because you see lots more details. It will show you all the dimensions and what you can change on the property sheets, and it will list all the core sets and how they can be used. I'll quickly add a verge and a new basic wall subassembly. All this is happily updating in real time on my second screen. I'll drag the model viewer back over. I'll add another verge at the top of the wall and some extra cut and fill. I'll just need to quickly retarget the existing ground so the cut and fill is displayed. This is a normal procedure. Obviously, some of the properties of this wall subassembly are easy to understand, like I can change the height. But what I really want to do is I want to change the height to match the ground level so I don't have too much of a cutting down here at the bottom. I need to control its height along the corridor. I can see a profile coming up, but first let me move the model viewer back home. As for the new profile, well, let's not get too bogged down in detail. I'll simply offset the main alignment 6.8 meters, so it's in the approximate position of the wall, and then create a profile with the existing ground. Standard stuff. You can clearly see why this has gone into cut in this area here. So now I need to sketch in a new profile. I'll call it top of wall, it seems a decent name. And then using the good old Civil 3D profile tools, I'll draw where I want the top of wall to be. I'll have it high here and a bit lower there. Essentially, where there's no profile, it'll just default to the height on the properties sheet. I want to show this change live, so I'll drag back the model viewer. Screen space is tight, and you can just about see I've selected the corridor, and on the ribbon bar I've chosen Edit Targets, and this brings up this target mapping box. Let me collapse all the other subassemblies apart from the wall one, and you can see the entry Step Profile, which if I click it, it lists the profiles to target. And there it is, top of wall. Just tick Rebuild Corridor and press OK. Job done. Looking at this, you can see the result. The height changes as advertised. Changing the settings in the model viewer will view the sections. And I think this is probably the easiest way to visualize this, especially when it's maximized to full screen. Again, I'm going to send this back to my second screen for now. Okay, that was, like I said, a bit quick and dirty. So take a look at the documentation to get a bit more detail. For example, attaching the wall to the corridor assembly was a little naughty. The footings would vary with the level of the verge, but the documentation points the way, suggesting making a new baseline so that you can create stepped footings at predefined levels. Enjoy! Now we do have a second new wall subassembly, a gabion. Again, look at the documentation. In this case, we'll look at having step footings. I'll spare you the detail, so I'll use the power of my video editing software to take out the individual steps. So let's cue some 1970s time travel music. Hey. So I've added a new baseline to the corridor that followed an alignment made from one of the corridor feature lines, created a ground profile, added a more intricate top of wall, and then drew a second profile to represent the footings. Simple. Let's bring back the model viewer and play with this gabion subassembly. The important thing with this subassembly is that if you wish to target a top of wall profile, you must change the height method, shown here, to target to profile. Now we can do lots of other things on this property sheet, such as change the draft angle of the wall, or how the front face is offset, even making it vertical. We can get larger baskets as we progress down from the top. We can ignore the top of the wall profile completely and force a height. And as you can see, this still all respects the footing level profile we drew with the baseline, and we can continue to alter and modify the design accordingly. Let's take it back off a fixed height. Hey, look at the documentation. It gives you far more detail. There's lots more to see here. Right, moving on, we have a couple of new underground services subassemblies. So let's work our way to the other side of the carriageway, and as before, remove the bits at the end and add a new verge. Now, we'll start with the high voltage utility trench, which defaults to having 3 ducts containing cables in a trefoil arrangement. I'll just change the cursor of the subassembly here to hide the tessellation points of the circles for our benefit to aid visualization. Again, lots going on here, so check the documentation, but the trench can contain a single cable of any colour, and both the older and new colour schemes are covered. Also, you're not limited to a trefoil layout. A flat one is also possible. Now let's look at the other one. This is a dynamic duct bank. This defaults to a 5x4 array of general ducts, but this can be changed to other configurations, and the sizes and gaps are all configurable. The idea is that you assign code values to identify their purpose. A nice little extra built in here is that you can turn off specific ducts by typing hide inside chevrons, like so. Dynamic duct bank. Now we're going to move on to quantity takeoff, which has been brought in line with the specification published for method of measurement in the Manual of Contract Documents for Highway Works. In a nutshell, and if you haven't used it before, the quantity takeoff system in Civil 3Ds allows you to assign extra data to your objects. This is very useful, for example, to count the number of trees you may need to plant. We're not going to look at numbering individual items, that's too easy. We'll start by drawing a polyline to work in linear meters, and then move up to looking at square meterage and then cubic meter quantities. The QTO Manager is on the Analyze tab up here. When you open it for the first time, you need to say what standard you're using. So we're going to tell it to open a pay item file. The UKIE stuff is inside the pay item data subfolder, and then inside the UKIE subfolder. The two further subfolders here contain the older standards, if you need them, but the one we want is the new MCHW set. We will come back to this box in a minute, but for now we will load the raw data into the table. We can now search for the desired method of measurement by choosing the appropriate ID or searching for a keyword. In the case of the polyline I drew, we will class this as a drain, identified here as CC500-0201. Let's look at CC500 on the Highways Agency site and open the specification document. You can see that the drains and ducts are section 2, and there are 2 items in the section, the first being a drain, hence the ID being CC500-0201. You can see that other sections of the document match up to the other IDs that have been filtered. To declare this polyline as a drain, just right click, choose Add and pick the polyline. It's that simple. Now this is classified, we can run a simple report. A summary will suffice. Don't worry about this messy XML variant right now. We can just view the report in HTML format. Voila! Now I mentioned we'd come back to the categorization file. Well, normally you'd add that at the same time as the data file. It's in the same folder. And when matched with the data file, this will add chapters and subfolders so that you can navigate through the specification. Here, for example, are the drains and service ducts. And you can always switch between the two views here if required. Let's work with something a little more complex. Let's try and quantify the amount of curbs needed in the corridor. Search for curbs and a sign seems a good start. Well, yes, that will work, but which feature line represents the curve, and have you selected all the curve edges? So no, I wouldn't do it that way. The better way is to assign the ID in the corridor properties sheet. Select the corridor, choose corridor properties, and click the feature lines tab and find the feature line name that matches part of the subassembly and assign the pay item by clicking the little truck icon. In this case, I'll choose the feature line back of curb because every curb has one, and I'll assign the pay item using the little truck icon and filter for curb entries, and I'll select CC207-0201. Then close the corridor properties sheets. Job done. And here's the report. Now let's look at the links. These will give us quantities of square meters. Looking at CC200, we can see different types of surface treatments, and we want to assign a high friction one. That's CC204-0101. Again, we could assign it to a drawn enclosed area, but the corridor code sets contain link codes, and these generate an area when the corridor is built. Making this easy is a little more complicated and involves editing the underlying code set, but let's do it. So we go to Corridor Properties, click on Codes, expand links and look for the pave code. That's the line at the top here, and you can get that from the subassembly documentation. It will point you in the right direction, but you cannot assign the values here. Instead, you need to edit the code set like this. But once you've figured it out, it all falls into place, and the quantities indeed are assigned appropriately. And of course, suitable square meter reports can be generated. Finally, let's look at assigning cubic meters. Let's figure out how many cubic meters of subbase we need to build our road. Now, the subassembly documentation identifies the shape code called subbase as the identifier. That makes sense. And searching through the categories, I can identify CC2010104 as a bound subbase material. But to link all this together, we need an object with a volume, and this requires us to export solids from both sides of the carriageway to be able to assign cubic meters. Let's do it. Highlight the corridor, choose Extract Corridor Solids, select only the subbase shapes from the right-hand side carriageway subassembly and the left-hand side carriageway subassembly. Then work through to extract the solids. Notice you're able to dynamically link the solid back to the corridor, so changing the corridor will later update the solid. Now, once the solids have been extracted into the drawing, you can assign their MCHW ID by simply selecting the solids on screen, after which a report can be generated that shows the volumes. You can also generate reports on all the IDs by unchecking this box here. Anyway, that's all for QTO. Let's move on to roundabouts. In order to demonstrate the new roundabout standards in the UKIE Country Kit, I'm going to add an existing alignment using my data shortcuts. And as you can see, this alignment matches that of the current carriageway. Again, using a data shortcut, I will also add an alignment representing a proposed link road so that we can look at the possibilities of creating a new roundabout to CD116 standards at the intersection of the two alignments at this point here. Now, firstly, if you have vehicle tracking available, you will find the roundabout tools on the vehicle tracking tab. But don't worry if your Civil 3D is missing these tools. They will still work without vehicle tracking. They can be accessed from the Home tab on the drop-down called Junction. Okay, I know, mine says intersections, but yours will probably be labelled as junctions. Just select Create Roundabout to choose the standard you need. The older previous standards are still available, and the new ones are under a separate folder clearly labelled with CD116. Of the 4 roundabouts supported, the normal roundabouts are the most flexible, with the mini roundabouts being the most difficult design, needing to be constrained to an existing junction. So for our needs, we will choose a compact roundabout based on single approach lanes, constrained circulatory lane widths, and a tight entry width. So the middly difficult one. Is middly a word? Probably not. Anyway, after choosing the roundabout type you want, click Proceed. I think it's good practice to accept most of the defaults for the variables here. We could change them later. One thing we need to change is the draw style. I have a white background. You may have a dark one. I will select a style suitable for my background. Now, and this is important folks, by editing this style we can get the layer names correct for GG184. Click the little 3 dots next to the style and change the base layer name up here. As you can see, I've looked up the Uniclass layer name for roundabouts, and I will copy this out and into the box. Then I've just got to modify so that it matches what we expect for GG184. Oh, and leave that little hash symbol at the end. This means if you build more than one roundabout, the layers will be separated between each. Press OK and insert the roundel on the alignment intersection. Let's just look at the roundel first. You can see a load of grips, which when you roll over them will tell you what their purpose is. This one apparently adjusts the inside lane offset, and this one the apron width. And if you click and drag the grips, it changes the appropriate dimension. This one here adjusts the inscribed circle diameter, or ICD. Notice that if I drag the grip to a point that makes the dimension too large or too small, then a warning triangle will appear indicating that it is outside the specification of a CD116 compact roundabout. Now, at any time if we click the roundabout, the ribbon will change to allow you to work with it. Roundabout properties is the go-to tool here to change most things, like for the example the draw style we set earlier, or if we dig down to the roundel dimensions we can change the values we originally skipped, or examine how the standard works. Now, as with all the UKIE stuff, there is documentation. Let's open the standard user guide and then follow the index down to the roundabout overview. This points you to a separate document that focuses on just CD116. Follow the link to open it. And look, this is a roundabout documentation. Look for the compact roundabout roundel information in the index and click to take you there. As you can see, the figures are justified based on entries taken directly from CD116, and explanations are given for certain assumptions. Let's change lane width. And whilst lanes can be between 3 and 6 metres, the important constraint here is actually the circulatory width, which may change with a combination of variables on this sheet. So everything is interlinked. As a further example, notice our change also updated the ICD, but it still meets the standard as all the variables are within the declared range, and of course this means no warning triangles. Let's add an approach, selecting the northern side of the roadway alignment. Again, I'll leave the defaults and I'll change them later. That's the sort of guy I am. I'll also add a second on the southern side, and as you can see the roundabout has arms, or is it legs? Now things are starting to clutter up, but I've no red triangles, so it's so far so good. However, I will address the clutter with a little bit of layer management, freezing all the curbs, lineage and so forth. That's better. Now when we look at the roundabout properties, the arms of a roundabout are now included, and I can see and change values on them individually. In this case, I will push the departing lane of the southern arm to expand into 2 lanes. Done. Still no red triangles. Still good. Now it's time to add the final arm to connect the link road. This will be defined on a curved section of the alignment. Let's see what happens by accepting the default. Straight away a couple of red triangles, and this can be solved by playing with the grips, altering the interarm radius or the entry radius. However, let's take a big time out here. Let's just break it once more. Bear with me, because I've read the specification for compact roundabouts, and whilst it doesn't explicitly say it, it does sort of imply that an entry width of 4.5 metres is ideal. The entry width is measured across here and is not determined directly, and on the whole is defined by these radiuses, but other variables also play their part in affecting its value. Now let me split the screen, and in roundabout properties I'll look at the annotation settings under heads up display, and I'll increase the data this heads-up display shows. Let's do a little zooming so you can see it easy. And now I have the exact value of that entry width. This means I can experiment with the grips to achieve the exact entry width I want for this design. However, I'm not always happy with designing just using the grips. It's a lot better to input exact figures, and of course the roundabout properties sheet is the place to do this. Here you can see the range that's built in for the flexibility for the entry width. I have found it's best to alter the splitter entry radius to fix issues with the entry width. In this case I'll change it and you can see the result. Whilst within tolerance, doesn't quite hit the ideal value of 4.5. I just need to choose something more suitable. Maybe this. Yep, nearer. Also changing the outer entry radius has a pull on this entry width. Something silly? Yep, that obviously broke it. Maybe a nice round 15 will do it, and a splitter radius of say 40. Yeah, that'll do. Nearly spot on 4.5. Like I say, many variables affect this key driven dimension. The deflection of the approach is also an influence. Let's change that to 5 meters. Yay, spot on. Now, I've avoided showing you this next bit because I was keen to use the live model to get a feel of the build. But there's a great preview you can switch on to complement the roundabout properties sheets. Click this button here and position it where you want. When you click on the data fields, a nice visual appears. There you go. The deflection will alter the underlying alignment slightly. And that's great for building mini roundabouts. Let's add a central gap. The graphic makes sense. Press apply and done. Almost all the fields have similar preview graphics and help you understand what you're actually controlling in a friendly pictorial fashion. But don't let these fancy graphic previews take your eye off the big picture. Finally, and I've speeded it up, I'm just going to add a splitter island to the northern arm and then include a zebra crossing on each side. And remember that switching those layers back on will provide you with crown lines, fastest paths and signage, the big picture. At the start of this video I promised to show some advanced ribbon handling techniques for UKIE. Let's start by looking in detail at the ribbon. And maybe you haven't spotted this, but if you toggle the tool palettes on and off, the colour of this ribbon icon changes. This icon is now on the Home tab too. So this isn't just a common old garden AutoCAD menu. First things first, if you need to switch the UKIE ribbon off, and maybe you've already added these functions to your corporate ribbon, firstly exit Civil 3D and navigate into Program Files, Autodesk, Application Plugins. And here you'll find the UKIE Loader plugin. Simply rename the .bundle extension to something else, and this will basically stop the UKIE ribbon loading. Renaming the folder back will of course re-enable it. Looking inside this folder you'll find a contents folder, then a Windows subfolder. In here is a UKIE config XML file. Be careful here, so make a backup and copy it to your desktop, then edit it with something like Notepad. There are a number of keys to change here, taking true or false values. The Add Button code decides whether or not the colour changes on that tool palette icon we saw. The Add UKIE to Home button key does what it says on a tin and updates the top level ribbon bar to include the UKIE tool palette icon. Setting Move UKIE tab to True will always move the UKIE ribbon to its default position next to the Vehicle Tracking tab, and we'll cover the final option in a minute. Any changes you make will need saving and copying back to replace the original in the bundle folder. Restarting Civil 3D in this case will ratify the changes, and straight away you can see that the home ribbon is missing the UKIE tool palette icon, and when you move the UKIE ribbon it will now remember its position between reboots. The final option turns off a warning dialog box. Now this is only triggered if you run Civil 3D under a profile that's not UKIE. Watch, I'll start a non-UKIE variant of Civil, and when you try to open the tool palettes it presents this warning. You may wish to switch this message off if you're using a company profile that's been customised to mix UKIE with content palettes from elsewhere. Disable it by changing the option to false. Well, that's all from me for now. Expect a 2027.1 release of UKIE in October or November, and no doubt I'll be back next year with another instructional video to help you keep abreast of any new stuff. Bye for now.